This lesson is on indefinite integrals with an initial value of c. We call this initial or fixed value problems, and so we'll start with just a generic example that doesn't have a word problem associated with it, and it is this. It says find the function f if it is known that f prime of x equals 3x squared minus 4x plus 8 and f of 1 equals 9. So this f prime of x, remember, is a rate of change. And so if you want to go backwards, then you can find the antiderivative to find f of x. So it's important that you understand this notation, and I would continue to write it out if I were you. The integral of the derivative of f is equal to f. F of x equals the integral of f prime of x dx. This integral sign and this dx go together. You can't write one without writing the other. So I would pay attention to notation because it's important for U substitution. Okay, so if we're not given any limits here and here, remember that's an indefinite integral, and we must add a plus c to our f of x. But sometimes we're given some information like a point on the line, and so we can use that point to find the value of c at that point and replace c with that value. So let's just go through that here. So we have this derivative f prime of x, and so the notation would be we want to go backwards and find f of x, and so f of x is the integral of f prime of x dx. So we can't write this without writing that. F of x is the integral of f prime of x dx. Well, that means that f of x equals the indefinite integral of 3x squared minus 4x plus 8. And so if we take the antiderivative, f of x equals 3 times x cubed over 3 minus 4x squared over 2 plus 8x plus c. So f of x equals x cubed, because the 3's divide out, minus 2x squared plus 8x plus c. So this is the function, but we don't know the constant here at the end. However, we are given when x is 1 in that function, we have 9. So we're given this ordered pair 1, 9. So we can put 9 in place of f of x and 1 in place of 3. And get 9 equals 1 minus 1 squared is 1 times 2, which is 2. 8 times 1 is 8. 9 equals 1 minus negative 2 is negative 1 plus 8. That's 7. Subtract 7 from both sides. 2 is c. So now we found the value of c, and so our function is f of x equals x cubed minus 2x squared plus 8x plus 2. Okay, so our next example is a word problem found in your lab manuals, number 4. It says a roast is taken from the refrigerator and placed immediately in a preheated oven to cook. The change in temperature of the roast is estimated by the function r prime of t equals 1.4 e to the negative 0.005 t, where t is the time in minutes. If the temperature of the refrigerator is 45 degrees, what was the temperature of the oven of the roast after 1 hour? Okay, so the first thing we want to notice is that there is a prime here, which means this is a derivative, but this, I didn't have to give you that. So you really have to be good at reading the problem and understanding that this is a rate of change. So the way we know that is because it says it's the change in temperature. So this, when you know the time in minutes, you'll know the change in the temperature per minute. Okay, we know t is time in minutes, and we also know that the temperature of the refrigerator is 45 degrees. And what we want to know is we want to know what the temperature of the roast is after 1 hour. So we have to create a function that tells us if we know the time, we'll know the temperature. And again, this function doesn't give us a time versus a temperature. It gives us a time versus a change in temperature. So what we have here is this r prime of t right here gives us the temperature per minute change. And if we have a temperature per minute change, we can create a r of t, which is a function that gives you, if you know the time, you'll know the temperature. And so we do that by integrating. And I would write down the notation so I can get used to it. The integral of the r prime of t function dt is going to give me the r of t function, the temperature function. So if I work backwards and take the antiderivative of the derivative, I'll get a function that gives me temperature when I know time. Okay, so I'm going to substitute in the function, and it is 1.4 e to the negative 0.005 t dt. So if I want to take this antiderivative, I have to use u substitution because there is a power other than just x there. So to do that, first of all, I'm going to pull the constant out. So we have 1.4 times the integral of e to the negative 0.005 t dt. We're going to let u equal negative 0.005 t. We're going to take the derivative of u with respect to t. That gives us negative 0.005. And if I multiply both sides by dt, I get negative 0.005 dt. So I have u and I have du, and I'm going to substitute. Well, this is e to the u, and I need 1 dt. Well, I don't have 1 dt. I have negative 0.005 dt. So if I multiply both sides by 1 over negative 0.005 dt, then I'll get what I need. And so this is 1 over negative 0.005 du equals dt. So now I can substitute. So this is going to be the integral of this 1 dt is going to get replaced. Excuse me, that should have been dt. This 1 dt is going to be replaced with this. So that's 1 over negative 0.005 e to the u du. And I got to bring that 1.4 down. Okay, so now this is a constant, so it can come out. So if I take this constant times that constant, I get 1.4 over negative 0.005 e to the u plus c. This is what r of t is equal to, but then the last step is to put the u, substitute back out, so that would be negative 1.4 over 0.005 e to the negative 0.005 t plus c. So I have my function, and hopefully this is the last time that I will use u substitution for this type of function. It's way too much work. I wanted to do it because I wanted to say you can only use the shortcut when this is linear. So if this were a t squared, then you can't use the shortcut. And the shortcut, just notice what it is. If I want to take the antiderivative 1.4 e to the negative 0.005 dt, all I have to do is take that coefficient, the negative 0.005, and divide it into the constant. Now, if this were a t squared, I'd have to do all of this work. But if it's a linear e function, I'm just going to take that power and divide it into the constant. So there it is. That's our r of t function, except one problem. This is an indefinite integral, and so I have to have a plus c at the end. So if you go back and look at the problem, there must be something given, an initial value, and it is here. If the temperature of the refrigerator is 45 degrees, what is the temperature of the roast after 1 hour? So if the temperature of the refrigerator is 45 degrees, Well, this function right here, this R of t function, tells me if I know the time, then I'll know the temperature. And this is saying that at time 0, the temperature is 45 degrees. So I have a point, and my point is 0:45. So what I'm going to do is put 45 in for R of t, and then I'm going to put 0 in for t and solve for c. And so 45 equals, and then we would need to figure out what this is, but I'll do that in a minute. But this e to the 0 is 1. So this gives me this value plus c. So then if this is 45 equals negative 1.4 over 0.005 plus c, then I can add positive 1.4 over 0.005 and get c by itself. So now I'm going to have a function with c in there, and then I'll be able to answer the question. I'm going to figure what that is when I go to Excel in just a second. But remember, there was a question, what is the temperature of the roast after 1 hour? So I'm going to have an R of t function. R of t is equal to this plus whatever that value is, and then I'll be able to plug after 1 hour. Now 1 hour, remember t is in minutes, I'll be able to find, if I plug 60 in, I'll be able to find R. So I'll go to Excel and do that right now. Okay, so now I can figure out what these values are. So equals 45 plus 1.4 divided by 0.005 is equal to 325. So my R of t function would be negative 1.4 over 0.005 e to the negative 0.005 t plus 325, right? Okay, so now I want to use this function, and I know that the time is 60 minutes, and if I use this function and plug 60 in for t, I'll be able to find the temperature of the roast. So I'll just do that right here. So this would be equals negative 1.4 divided by 0.005 times exp parentheses negative 0.005 times 60 plus 325. And I get the temperature of the roast after 1 hour is 117.6 degrees Fahrenheit. Okay, so we'll take a look at another one. It's number 7, and it says the management of the National Electric Company has determined that the daily marginal cost measured in dollars per unit associated with producing their automatic coffee makers is given by the derivative of c with respect to x equals, and then we have this function where x denotes number of units produced. Management has also determined that the daily fixed cost incurred in producing these coffee makers is $500. The question is, what is the total cost incurred by National in producing 400 coffee makers per day? Okay, again, you're given the notation for a derivative, but we didn't have to give you that. Really what you need to see is that this is a marginal cost function. This is a marginal cost function. So this is a rate of change, and we want a total cost function. This function gives you, when x is known and x is number of units produced, it'll give you the cost per unit. And we don't want that. We want the total cost. So that means we're going to have to take and we're going to create a cost function, a c of x function, and it is equal to the derivative of c with respect to x dx. And remember, this integral symbol and that dx goes together. And so we'll do that. It's an indefinite integral because we don't have any numbers here and here. So we'll substitute in the integral of 0.00003 1, 2, 3, 4, 4 zeros, x squared minus 0.03x plus 20 dx. And that means that your cost function is equal to the antiderivative here would be 0.00003 x cubed over 3 minus 0.03 x squared over 2 plus 20x plus c, and then I'm going to use the capital K because this is a cost function, so sometimes we'll change that letter so it's clear. So we have to put the constant because it's an indefinite integral, but we're given a daily fixed cost. So that is telling me that when 0 items are made, because x is number of items, then 400 coffee makers are made. So this is a daily marginal cost function. So this daily here isn't really important. That's encompassed into the cost function. So fixed cost means when 0 items are made. I'm sorry, I used the wrong letter. Number $500 is what it's going to cost. So let me underline that. The fixed cost incurred in producing these coffee makers is $500. Okay, so this is X. 0 coffee makers made. It's going to cost $500. So this is why we call this initial value or fixed value problems. Okay, now I can do this without using Excel. If we put 0 in here and 0 in here and 0 in here, to see how these terms all cancel. If we put 500 in here, we're going to have 500 equals this, which is 0 minus this, plus this, which is all 0. So 500 is equal to K. And so our function is just the daily cost function is this with the 500. Now the reason I did number 4 first is because I don't want you to always think that whatever your fixed value is going to be what your constant is. That's not always true, particularly if you have an e function or some different type of function. A polynomial function, when you put 0 in here, everything cancels, but you can see from back number 4, you put 0 in for t and you got something for c that was not trivial. So please, please, please do the work that's required to get the constant here. This one is an easy one because it's a polynomial. Okay, so now I have 2 functions that I can work with, and I'm just going to put both of them in. So my derivative is 0.00003 times x squared minus 0.03 times x plus 20. And my cost function gives me a total cost is 0.0003 divided by 3 times x cubed minus 0.03 divided by 2 times x squared plus 20 times x plus 500. And the question is, what is the total cost incurred by National in producing 400 items, which are coffee makers, per day? And again, the per day is part of the daily. This is not a rate of change. We want to know, when we know the number of coffee makers, what's the total cost? If I put 400 here, then the total daily cost is $6,740. But just as a way of review, that derivative, that 12.8, is at 400 coffee makers. The daily cost is increasing at a rate of $12.08 per additional coffee maker. Or it's a marginal, so we would use the marginal way of interpreting. The 401st coffee maker is going to cost $12.80 approximately. So you have to be able to understand what both of these functions are giving you. One's a rate of change or a marginal cost, and one is a total cost in this problem. Okay, so number 2 says a beverage distributor has determined that the daily marginal profit can be modeled by the function derivative profit with respect to Q equals negative 1/5 Q plus 1, where Q is the number of cases in hundreds sold each day and P is in thousands of dollars. The distributor has a negative initial profit of 1,000. So I'm just going to look at the key here, and what's noteworthy about this one is that your units are not simple. They're in hundreds and thousands. So it says that Q is number of cases in hundreds. I wrote that here. P is in thousands of dollars. So P stands for profit in thousands. This is the marginal profit. Question A says find the function P of Q that describes the distributor's total daily profit. So this is marginal profit, a rate of change, and we want to create a total daily profit function. So that involves taking the integral, the indefinite integral. So you're definitely going to have a plus c involved. So the antiderivative of negative 1/5 q is negative 1/5 q squared divided by 2, which is negative 1/10 q squared. The antiderivative of 1 is 1q, and then this is a polynomial, so there would be a plus c. Okay, so then you're looking for a fixed point or an initial value, and it says the distributor has a negative initial profit of $1,000. So that means when you have 0 cases sold, then your profit is negative 1,000. Okay, but P is in thousands, so you can't stick 1,000 into this profit function. You have to divide out the 1,000. So what happened was, if we put 1 right here in for P of Q and put 0 here, again it's a polynomial, so 0q squared will go away and 1 times 0 will go away. So it turns out that you got negative 1, and it would be a negative because it's a negative profit. A negative 1 equals C. So that's how I got negative 1 right there. Just wanted to go over this one because the units were something to be paying attention to. So we now have our profit function. And then it says how much money will the distributor make if they sell 300 cases. So here I have my Q is my input, and my total profit function is next, and my marginal profit function is here. This question is asking you to use a function that when you know the cases, you know the profit. Not the change in profit, just the profit. And remember, Q is in hundreds, so if you plug 3 in for Q, your profit is $1.1 thousand because profit is in thousands. So if we take this and multiply by 1,000, we get 1,100. So if 300 cases are sold, the profit is $1,100. Second question, or third question, what is the break-even quantity? So remember, that is where the profit is 0. And so I created a domain, and then I graphed it so I can see my quadratic, and I've got guess points here of about 1.5 and maybe 10. So I put guess numbers here. And then to find the break-even points, you goal seek profit to 0. And then the second break-even point, okay, so that means that the break-even quantities are 112.68 cases because this is in hundreds, or 887.36 cases because this is in hundreds. In question D, how much must be sold to achieve maximum profit? And remember, that's an optimization problem. To find maximum profit, you take the derivative, which I have here, and goal seek it to 0. Not needed because there's already a 0 here. And so the maximum occurs when 500 cases are sold, and the maximum profit would be $1,500. So just wanted to go over that one quickly because of the units. You have to remember what to do there. Okay, the last one says the concentration C of lidocaine in milligrams per milliliter is changing at the following rate per hour. C prime of t equals negative 1.2 e to the negative 0.01 t, where t is the number of hours after injection. A says how fast is the lidocaine changing after 3 hours, and B says if the original dose was 5 milligrams per milliliter, determine the formula for concentration of lidocaine in the first t hours. So we've done a bit of editing. I had to edit my video. We've changed the problem a little bit. So try to ignore all the writing. But I wanted to go through and make sure you understand that this is a C prime of t, but the prime is not what gives it away. What gives it away is the words changing at a rate. So this, if you know the time in hours, you'll know the concentration, the way the concentration in milligrams per milliliter is changing. And so question A, how fast is the lidocaine changing, tells me that I want to use this function. I'll plug 3 in to this function. B says if the original dose was 5 milligrams, determine the formula for the concentration of lidocaine. I need a concentration formula. Right now I have a change in concentration formula, but I need a concentration formula. So that concentration formula comes from integrating, finding the antiderivative of the rate of change formula here. So a couple of things to remember. This is an E function and we're given a derivative. So to get the antiderivative, we're going to take the integral of the derivative. And now I'm going to use the shortcut. So that's going to be negative 1.2 over negative 0.01 e to the negative 0.01 t plus c. So again, if this is a linear power, you just divide by the leading coefficient and you're done. Let's call this k since there's a function named c here. And this is our original function. Now here's our initial value. This is saying the original dose. So at 0 hours they got 5 milligrams per milliliter in the body. So I need to plug 5 in for C of t and 0 in for t. So 5 equals negative 1.2 over negative 0.01 e to the negative 0.01 times 0 plus c. And I started this way and I'm ending this way. This e function, e to the 0.01 times 0, e to the 0 is not 0, e to the 0 is 1. The negative divided by negative positive. So this constant isn't going to be trivial like the other two examples because we had polynomials. This constant is going to be 5 minus whatever 1.2 over 0.01 is. And that's going to be our function. So I'll go back to Excel in just a second. But again, t is hours. C of t is concentration in milligrams per milliliters. And this C prime of t right here is the change in the concentration, milligrams per milliliter per hour. So those are the two functions. This one says how fast, that's a hint. Is the lidocaine changing? So this one you're going to be using your C prime of t function. So I'll do all that in Excel to finish up. Okay, so the first thing I'll do is figure out what my k value is. So that would be 5 minus 1.2 divided by 0.01. And so that k right there needs to be replaced with a minus 115. Okay, so here is the function, and you would want to rewrite it. C of t equals 1.2 over 0.1 e to the 0.01 t minus 115. And now I can answer the first question, how fast is the lidocaine changing after 3 hours? I put the 3 in, and which function would I use? This is the rate of change, so I would use this rate of change function. And I get that value. Just want to make sure I typed it in correctly. Okay. How fast is the lidocaine changing after 3 hours? And you would say at 3 hours, the concentration is decreasing at a rate of positive 1.16, and the units are milligrams per milliliter per hour. And that is the answer to A. Question B, we had to find K and then just determine the formula. So question B is this function right here, and we don't need to use it. So that's the end of that problem. Okay, so just to wrap up, I just want to reiterate, see this problem here? We began this way, we're going to end this way. The original dose was 5 milligrams, 0.5, but see that K is not 5? That's because with this E function, e to the 0 power isn't 0. E to the 0 power is 1. So that gives you a constant K that's not just exactly what you started with. But on these polynomials, your initial value is going to be what C is. So I started with one that was non-trivial. C wasn't 45, C was 325, and I ended with one that was not trivial. C, you started with 5, but you ended with negative 115. So please make sure you're aware of that when you're finding these values of C.